This lesson is over solving literal equations. A literal equation is an equation with two or more variables. We're going to solve a literal equation the same way that you solve any other equation by using inverse operations. Sometimes it can be a little bit trickier because there are so many variables, but if you just treat the variables as if they were numbers and combine your like terms or your like variables, it really shouldn't be any different than solving any other equation. The first example is pretty simple and not really something that is out of our comfort zone. So it says solve the equation 3x plus y equals 10 for y. And then it goes on to ask us what does y equal if x equals 1 and if x equals 3. So we're used to seeing equations with x's and y's. That's why it's not really that big of a deal. To get the y by itself, you would need to get rid of the positive 3x that's being added. So you would have to subtract 3x from both sides, which would give you a positive y equals 10 minus 3x. Now, if that question, the original equation was 3x minus y, you would need to bring down the negative with the y, and then you would need to get rid of that negative as well. Just thought I would mention that because this one is so simple. So we subtracted 3x from both sides, and now we're going to answer the second part of the question, which is what does x equal, or what does y equal if x equals 1? So we're going to go ahead and plug in 1, which would be y equals 10 minus 3 times 1. We would use the order of operation. 3 times 1 is just 3. So 10 minus 3 will give us our answer of y equals 7. So when x equals 1, y equals 7. The next problem asked us what if x equals 3. So we're going to do the same thing. We're going to plug in 3 for x in this case. 3 times 3 is 9. So y equals 10 minus 9, which is 1. So that's our first literal equation. Like I said, it's pretty simple. It just had an x and a y, and it was a one-step equation to get y by itself. The next example is a little bit trickier. It says solve 3x minus 2y equals xz plus 5 for x. So our goal is to get x by itself, and if you look, we have 3x on the left-hand side of the equation, and then we have xz on the right-hand side of the equation. So this one is definitely more complicated than the last one that we looked at. I'm going to try to get my variable x alone on the left-hand side of this equation, so I'm going to go ahead and get rid of subtracting 2y from both sides first. The opposite of subtracting 2y would be to add 2y to both sides. On the right-hand side of the equation, there's not a like term that I can combine the 2y with, so you're just going to leave it as xz plus 5 plus 2y. Now what I'm going to do is I'm going to get the term xz on the left-hand side with the 3x because my goal is to get the x's isolated. Now 3x minus xz are not like terms, so it has to stay a subtraction problem right now. So we have 3x minus xz equals 5 plus 2y. Now, if you notice each term, 3x and xz, both have an x in them. So I can almost do the opposite of the distributive property, or I could factor out an x and say x times, in parentheses, 3 minus z. Notice if you distributed that x, you would be back to 3x minus x times z. And we're going to bring down equals 5 plus 2y. Now to get x by itself, I need to do the opposite of multiplying by 3 minus z. So I need to divide both sides by 3 minus z. And when I do that, I get my answer of x equals 5 plus 2y divided by 3 minus z. The next example says, what equation do you get when you solve the equation a over x minus b over x equals c for x? So again, my goal is to get x by itself. If you notice in this case, you're subtracting two fractions or two ratios, and both have x in the denominator. So I can actually write this a little bit, or a simpler way, in order to solve for x, I can just write it as a minus b over x equals c. My goal is to get x by itself, and I do not want x in the denominator, so I'm going to go ahead and multiply both sides by x. The x that I'm multiplying on the left-hand side will cancel out with the x in the denominator because x divided by x would just leave you with 1. And then we're going to multiply c times x as well. So that leaves me with a minus b equals c times x. Now you're multiplying c times x. The opposite of multiplying by c is to divide by c. Again, now on the right-hand side, my c's would cancel out and leave me with just x. So the answer is a minus b divided by c equals x. The last example says the largest yo-yo in the world is 32.7 feet in circumference. It was launched from a crane at 189 feet. The formula for the circumference of a circle is circumference equals 2 times pi times r, where c is the circumference and r is the radius. The first thing they ask us to do is A, solve the formula for r. If you notice in the formula, c equals 2 pi r, you're multiplying 2 times pi times radius. We want to leave r alone, but I can divide that whole thing by 2 pi. And whatever I do to one side of an equation, I have to do to the other side. So both my 2 and my pi would cancel out on the right-hand side, leaving me with just the radius equals the circumference divided by 2 times pi. If you remember, pi has a value of 3.14. I don't believe we've talked about that in this class yet. Probably something that you already know, but just a reminder in case. And then because B asks us to find the radius of the yo-yo. So if we reread the question, again, it told us in the original statement that the circumference is 32.7 feet. So we would plug in 32.7 for the circumference and divide it by 2 times pi. And when we do that, we find that the radius would be about 5.2 feet, which is a very large yo-yo.